Welcome back to our Drivetrain video series where we're CADing it in Solidworks. In our last video we finished the frame of the drivetrain, and in this video we'll be adding in the components of the drivetrain. In the following video we'll be designing a belly pan and possibly designing a battery mount, depends on how I'm feeling. So this will be the second part of this video series. Let's get started. So next to the new tab or the new button in the top tab of SolidWorks is the open button. We'll click that and open our drivetrain assembly from last time. So open. And this is what we had. This is where we ended off. And we're going to start today by adding the gearboxes onto our drivetrain. So let's get started with our gearboxes. So on VexPro, we're going to be using the West Coast Products gearbox, one of theirs, because those are very easily integratable into a West Coast style drivetrain. So there's either the dual speed gearbox or the single speed gearbox. We're going to be using dual speed. The difference is that dual speed provides your robot with two speeds to shift between versus a one speed, single speed gearbox. And the difference here too, design wise, is just that it adds in a little bit more of a complication having a shifter and a piston. But yeah, it has its benefits, has its disadvantages, so something to decide between for your drivetrain. Typically they're very good to use and they're very worth it, but it depends on your team, I guess. So when we're ordering this gearbox and when we're downloading the CAD file, if we're doing it for West Coast Drive and we want that West Coast Drive kit kind of, we're using the West Coast Drive base kit. So download that and you can see the difference here. This has space in between here for you to add sprockets and the bearing block that we are using as reference in our frame. So this bearing block is what's going through the material versus the normal gearbox where there is no bearing block included and no space inside for there to include sprockets. So yeah, we have this file downloaded. However, I'm going to copy and paste it into our project folder, and I'm going to create a gearbox folder within Drivetrain. And the reason we're doing this is because this is an assembly. The step file will be an assembly, and when we save it, it's going to save all the components within the assembly. So if our step file was in downloads and we save the assembly will be in our project folder, but all the parts will still be in downloads. So we got to move the step file into our project folder and then open it and save it. And the reason we want it all within our project folder is because when you're working with one or more designer, or when you're working with more than one designer, you have a sharing platform for sharing all of your files. GrabCAD Workbench, for example, is one really good sharing platform for CAD files. But typically with this, weird assembly thing still happening. Typically with this, you keep all of the files you're sharing within one project folder. So anything that's outside of your project folder but on your laptop might show up for you, but if it's not in that folder, it's going to show up as a missing component to someone else. So that's why we try and make sure that all of our stuff, let me save this, all of our stuff is in that one main folder. So let me save this into here. Yeah, so if you do come to a point where you have some parts outside of your project folder, you can move them, but not by dragging from folder to folder like you would normally do on your laptop. You have to use a SolidWorks manager or something to move your folder or to move your part into where you want it to be. Or if you have an assembly or something like this, you can use pack and go, and that pretty much packs all of the parts within this assembly into a folder, and you can save that folder wherever you want. So that's really handy if you have your full robot assembly and it's pretty complete, but some of the parts are missing to other people. So pack and go all of the stuff and then give them the folder. That does get messy, so try to avoid that. But that is one solution. So here's our gearbox. We're going to add this into our drivetrain assembly. Also, you may notice that our assembly looks a little bit different, as in there's no lines. I changed that here, so lines, no lines. It helps our Solidworks run faster when you add in more components. So let's add this in here. Let's mate this to be concentric with this, and this works with circular object. It's basically like make circles in line with each other. I'm also going to make this parallel here so it just doesn't spin and move around. So yeah, with this, when you actually build it, you would bolt the bearing block through the material and into the gearbox. So I'm going to do the same thing on the other side. Even though we can vertically mirror it, it's going to, like, when you mirror it, it's going to mirror kind of weirdly. And then if you want it to actually be a reflected version, you have to mirror like it opposite hand or something. And you have to save the mirrored file, and it gets a little weird. So it's just easier to, for the gearbox at least, add in it here. So we have our gearboxes in our drivetrain, but we don't have the sprockets in yet. So let's go back to that. So this is our gearbox. We want to add in our sprockets, so we're going to be doing some mating and editing in this assembly. So we got to fix everything down, because from the step file, even though it's an assembly, nothing's mated to each other. So if we try and mate something else or move apart, it's just going to move and not stay in the same position. So what we just did now is fix everything where it is into position and locked it down. So I downloaded this sprocket earlier. So let me do that. Let me show it up. So we're going to be using the hex bore sprockets, and we're using 18 teeth. So I have that downloaded. I'm going to insert that. I save that under power transmission. And I'm going to flip it this way. It doesn't really matter though. I'm going to mate that right here. And we do want in between kind of parts in motion, so like a sprocket against a bearing or a sprocket against a sprocket, we don't want them directly next to each other and rubbing against each other, because we don't want to break it. So we put spacers in between them. Spacers are also good if you want to keep objects in position, and you'll see a better example of that later in this video. Delete this right now. Add in. I also downloaded all these spacers, so let me pull that up on VexPro as well. So we're using these spacers, and we're using the 1/2" hex spacers because it's a 1/2" hex shaft. So I downloaded all of these, and make sure to include the materials in them as well. So this is Delrin under plastics in Solidworks. So let's add a 16th. For the gearbox itself, we're not adding materials just because it's a lot of stuff to add materials to, and VexPro provides the weight for that. So in your weight calculations, you just add on the weight of this gearbox into it. For things like bearings though, you'll find that VexPro also doesn't provide the materials. So for that, bearings, just because bearings are a little complicated and they have several different pieces, they don't weigh that much, so don't worry about it. For our next sprocket, because we have two, this is in the middle, it's going to go one sprocket to the back wheel and the other sprocket to the front wheel. We can either insert the component again, or this is a little shortcut method for things that are really close to each other. You can just hold Control, click and drag, and then you get a copy of that piece. This only works for parts though, and not assemblies. Otherwise you'll just copy whatever part you're highlighting in your assembly. Oh, did I do that right? Yes, that should be right. Okay, so I'm gonna add in 1/8 spacer. Okay, yeah. And when you finish this, the gap in here, there will be a small gap. However, it's only 0.03, which is smaller than a 16th, the smallest spacer there is, which is like 0.06 something. If it's smaller than that, then the gap shouldn't matter. Like it's so small it won't do much damage. So we're going to leave that like that. But yeah, with this, make sure to add the materials for your spacer and also your sprockets. So I've already done that. And if we go back to our main assembly, you'll see that these are in here now. Hooray! So now we can get started on the outer wheel assemblies. So I downloaded the VersaBlock, which is this thing. But I downloaded that. I also downloaded the bearing to go inside of it. And make sure to add materials. I used a flange hex bearing. So I used this one. And what I did with that is I had the VersaBlock and I just created an assembly. Let me open it. I just created an assembly of the VersaBlock and the bearing, and I just mated the bearing into there. But let me show you how this fits in. Yeah, so this is the VersaBlock. And I'm creating an assembly of this just because we're going to be inserting quite a lot of these, and I don't want to have to do this every single time of putting the bearing into the block and then mating the block to the material. So I'm doing it once, saving it as an assembly, and then I'm just inserting it into my assembly as this. So you can see there's a little ridge here. This face is also the face that clamps against the face of the material. So this bearing is going to be held in just from it being pushed into the bearing block. Okay, and made it into there. Cool. So this is what it's like. And yeah, it's not going to come out because it's being pushed against its flange into the block. So now we can go to our, I can close this because I'm done with it. We can go to our drivetrain and insert our VersaBlocks. So you can see, like, we call them the dog ears at the top, sitting at the top of the bearing block. Make sure to flip that so that you have the correct drop center. So it's flat edge on top, because the flat edge is the shorter drop center versus the deeper one. So yeah. Line this up roughly here. I'm going to then use this to make it concentric with this. And then what I can do here is mate that into place. Or sorry, fix this into place. And we have to fix the assembly so then it doesn't move. And I can do the same thing here. I would do a horizontal mirror, but our vertical mirror is above our horizontal mirror at the moment. So if I horizontal mirror it, it won't see it in the vertical mirror. So I'll just do it quickly. Okay. And pretty much what we're going to be doing is we're going to create the entire assembly on this side and then mirror it vertically onto this side. So you'll see the rest of this happening later. So the next step would be to add in the wheel shaft if we were building this, but we got to figure out how long our shaft has to be. So what we're going to do is we're going to add the entire assembly and build the assembly of sprockets and spacers and wheels, and then figure out the length of that to find the length of our shaft. So first, we're going to say this wheel here is going to connect to this sprocket. So to figure out how far out our sprocket needs to be, we can measure here, going to here. Okay. And this is 0.28. So I'm going to stick a quarter spacer. And then we can put in our sprocket. I could do the copy and paste there, but then I'd have to move it here, so I'm just going to insert it. And I'm going to add a 1/16 spacer on here. Pretty much what we're doing is we're going to be adding a bolt, a washer and a bolt onto the end of this, at the end of this here. So secure everything in position. And we don't want that washer right up against the sprocket because we don't want it to be spinning right there. So it's going to be up against the spacer. I'll explain that in more detail and show you a more visual version of it as we build it. But that's kind of introducing it. We don't want the sprocket directly up against the washer and the bolts. Yeah. And now we're going to find out the distance of this. So this is 0.70. So I'm going to do 1/2 inch, 1/8, and I'm going to guess a 1/16 to get close to 0.7. Okay, let's measure here to here. 0.6. Pretty good. Now we can add in the sprocket. And then add in the 1/16 on the end. Okay, cool. So now we can add in our wheels on the other side of our sprockets and wheel blocks. So for your drivetrain, you typically use 4-inch wheels or 6-inch wheels. 4-inch wheels is standard, and if you need to get if there's some obstacles you need to drive over or something that are a little bit higher, you typically use 6 inches. You have to look at the geometry or whatever. But we're going to use 4-inch in this case. And for 4-inch wheels, I recommend using Coulson's. For 6-inch wheels, you can get that in a Coulson wheel from a different supplier. Vexpro doesn't provide 6-inch diameter wheels of Coulson's. But if you don't want to hunt for them, you can also get other wheels like traction wheels or Ploction wheels on AndyMart. We're gonna download, I've actually downloaded it. I downloaded, which one? One with a hex bore, this one. 4-inch, 0.875 width with a 1/2 inch hex bore. So I'm gonna put that in. I'm gonna add between the wheel and the material, or the wheel block, the bearing, I'm going to add in an 1/8 spacer rather than a 1/16, just because I don't want the wheel too close to my material. And then add in this for later. That will be on the end of our wheel, for the same reason that we put a 1/16 on the end of the sprocket. Okay, and now we can, this looks good. So let's mirror this to the other side. Actually, you know what we can do? We can just do this and deselect that, that, and that. You'll notice the Versa blocks are flipped the wrong way on the side. You can fix that. How you fix that is by doing this. Looking for the Versa block. And then you do, on this side, you click that, and then you can say create opposite hand version. So it should flip. Which one did I select? I have no idea. If you do that though, you're going to need to it'll just be a little complicated, so you can flip it if you really want to. Oh, here is this one. Actually, it seems to be fine. If you do flip it, so it's like that, you're going to have to save the mirrored versions of those parts. If you're fine with it, you can just leave it. But yeah. So now we're pretty much done with adding in the components. The only thing would be to put in the shaft. So you can do that if you want to. I'm going to do it for the sake of the video. But if you're CADing it and you are just going to build it, you don't need to add it into the CAD if you know that you want your shaft to be this long, and then you just cut it. So we're going to download the shaft. I've actually downloaded it already, but we are downloading the Thunder Hex shaft. So this is a hex shaft, and you can notice the difference between this versus Thunder Hex. So Thunder Hex has rounded edges and a hole going through the middle, versus Hex rough and solid. So the reason we want to use this is because of this hole. Pretty much we have all of our components stacked, and we're going to sandwich it pretty much. So we have all of our stuff and they're pushing against each other, and we're going to put the shaft through, and through this hole we're going to put a bolt and a washer behind the bolt to prevent this from sliding off, and the same thing on the other end, prevent that from sliding off. And this is a really good way to secure things in motion, because this is making sure that nothing moves in the system, because everything is being sandwiched. The other way you can secure things in motion is with a shaft collar. So this pretty much is like a spacer, but you can lock it in place wherever you want. So if I wanted my sprocket here, I don't need to spacers, I can just line it up with however I want and then clamp it with a shaft collar behind it and a shaft collar in front of it. And I can move that however I please. The only thing with this is that it can untighten and shift and move. It's not as reliable as the other system. You can get this in high strength though. Would still recommend using this kind of system. You can use this for smaller mechanisms, smaller parts of mechanisms that aren't as critical, critical, and has a lot of things relying on it. So I don't have the Thunderhex download, so let me download that. Okay, so this is our Thunderhex shaft. This is 18 inches. What I'm going to do is we're going to use configurations again. So I want an extruded cut that I can edit. So we've created a sketch on here, and I can trace out the outline of this for cutting it because I want to cut this shape, the entirety of the shaft. So I can either create a big circle or outline this, or I can just click this face and click convert entities, and it will create an outline of the outside of that shape. I'm going to use that. I'm going to cut extrude. So I'm just going to cut whatever, 1 inch. And now in my configurations, firstly, how long do we want to cut it? That's an important question. Or how long do we want our shaft to be? So from here to here, that's 4.1 or 4.01. And this is 3.58. Okay. So I'm going to make this one 4 inches because it's going to be hard to cut something that's 4.01 and it really doesn't matter. So we're going to do that. Doesn't matter that it's 0.01 inches off. So I'm going to do, 18 minus 4 is 14. And then to this configuration. And then back to default. I'm going to do 3.58. Just going to do 3.6. (18 minus 3.6 is 1440). Oh, and let's make sure to add the material to this too. 6061. Okay. And let's save this into stock. Okay. So now let's add this in. Let's add the other one in up here. And to mate this into our stuff, with all the other stuff we could concentric mate them because they were all circular objects. This, however, actually we can concentric mate. We can concentric mate this with the circles, but for the purpose of demonstration, I'm going to show you how to mate a hex object that doesn't have a circle. So what we do is we go to mate, we go to advanced mate, and we select width. So here on our shaft, we select a pair of sides, so right here, and we select a pair of sides in one of the hex objects on our system here. So another pair of sides. So now those are in line, but we want it inside the thing, with inside each other. So now we're going to select a different pair of sides on our shaft. So let's do top and bottom. And same thing on here. Line it up with that one. There we go. And then we want to coincident mate this to here. And now we have to select coincident. Cool. And for here, let me just do concentric. Cool. So now let me explain, or actually I've explained it. Let me download the stuff. So in CAD, you don't really put in this stuff. You don't put in the bolts and the washers because it's just so time consuming and unnecessary. You kind of just keep it in mind when designing. So make sure there's enough space to add in a bolt and enough space for the bolt head. But yeah, I'm just going to put it in so you can visualize it. I'm going to choose a flat washer for screw size 1/4. And I'm going to go with an OD of outer diameter of 0.5 or 0.75. So let's just download this one. So with the Thunderhex shaft 2, you'll notice how it's just a circular slot in here. It's not threaded or anything. So with this technique, you will have to thread the holes with a tapping kit for a 1/4 bolt. Should be good. So we're going to use this. Let me save it. And let me download the bolt. And I would use round head screws because socket head screws, the head is like very large. Flathead screws, you need a countersink hole to use. So rounded head just doesn't stick out as much. So we want 1/4 20. Length, 1/2 inch. So I'm going to go open that too. With this, let me hide this. If you do add bolts into SolidWorks, I would recommend suppressing the spiral and the thread, just because it'll make it run faster. So let me put this into here. So in the bolt, you tighten it into the shaft and it keeps everything inside. And it's pressing against the washer and against everything sandwiched here. And then you do the same thing on the other side. So it looked like that on both ends. I'm not going to do it for the rest, but that's what it would look like. And for this, before you assemble the gearbox, you would also cut down the shaft. So cut it down, and you would predict how much you cut it down in CAD. So the distance from here to here is 1.54, so I would just cut it down by 1.5 inches. So let's just do this in CAD. I'm going to create a shape because it's not easy as last time, because there's a circle and then this is not flat. So I'm just going to create a sketch, relation it to that point so that it outlines the entire thing, and then I wouldn't cut through into anything else I don't need to. So extruded cut. and 1.5. So it'd be like that. And same thing on this side. And then we're done.